Okay, folks, sorry about the dog in the last part of the video. We're going to finish up with equalities and do some more conversion factor problems and take a look at some density problems in this video. Okay, so we mentioned already that you can have metric to metric conversions and English to metric conversions, but you can also have different types of conversions such as speed, as where we have 85 kilometers per hour, and that means 85 kilometers equals 1 hour, and we can put that in a conversion. The same as if we have one tablet is 500 milligrams, we can put that also into a conversion factor. Let's move on. And here's another example where we have one capsule that is 250 milligrams. So we can put that all into a conversion factor. You can also have percent as a conversion factor. And if you have something that's percentage, it's simply that number over 100. And as we can see here, if we have 18% body fat by mass, we can make that 18 kilograms in 100 kilograms. And you can use grams, meters. It doesn't matter what your unit is. If it's percent, you can use whatever units you'd like. Okay. Parts per billion and parts per million. You have a certain number over, if it's parts per million, 1 times 10 to the 6, or over 1 times 10 to the 9. So let's take a look at some examples of writing conversion factors from equalities. If we have, for A, we have medication that Greg takes for high blood pressure contains 40 milligrams of propanol in one tablet. So 40 milligrams in one tablet. The problem says to write the equality, 40 milligrams equals one tablet. And then it also says to write the conversion factors. Okay, and the question also asks us to write the number of significant figures. So we have 2 sig figs for this problem. Let's move on to B. It says cold water fish such as salmon contains 1.9% omega-3 by mass. 1.9% by mass. So remember we said if it's a percentage, we can write that number over 100 and let's say grams. Oh, I'm sorry. 1.9 grams. 100 grams. And here we have your conversion. And we can also write that as 100 grams over 1.9 grams. Okay? Let's take a look at C. C says that the EPA has set the maximum level for mercury in tuna at 0.5 ppm. Well, ppm, the m is parts per million, so that's 10 to the 6, so that's just 0.5 over 1 times 10 to the 6. Okay? Sorry about that. Sorry about the dog again. Let's do the study check. It says that there are drops that are 0.15 milligrams per 1 milliliter of solution, and we're going to do the same thing. So I have 0.125 milligrams per 1 milliliter of solution. So that's just going to be 0.125 milligrams equals to 1 milliliter of solution. That's how I write solution in shorthand. So we can say for our conversion factors, oh, you know what? We didn't talk about how many sig figs we had in our other problems. We'll do it in this one. So that's 0.125 milligrams over 1 milliliter of milliliter of solution per 0.125 milligrams. And we have here 3 sig figs. All right, let's move on. This question involves conversion factors, and it says in a radiological imaging, such as PET scans, dosages of pharmaceuticals are based on body mass. If Greg weighs 140 pounds, what is his body mass in kilograms? Well, first we state the given and needed quantities. We need 100, well, we have 144 pounds and we need kilograms. Then we're going to write a plan for the given unit. So we need to go from pounds, and then we need a US metric factor to get to kilograms. Then here's our conversion that we use. 1 kilogram is 2.2 pounds. And now we're going to solve our problem and cancel out the units that we don't need. So says that Greg is 144 pounds, and we know that there are 2.20 pounds in 1 kilogram. So we want to know how many kilograms are in 144 pounds. So you always start with what you're given, and we're going to write, pounds. And you're going to write your conversion factor so that you're going to be able to cancel out your units. So you want your pounds to be on the bottom and your kilograms on the top, so your pounds will cancel. So that's 2.20, and then that's 1. And so when you put that into your calculator, let's see if I can get my trusty calculator to come up. Oops, sorry. No, I can't. I'll have to use my phone. Sorry, guys. So 144 divided by 2.2 is going to give us 65.45. We have 3 sig figs, 3 sig figs. So we need to round this off to 65.5 kilograms. Okay? All right, let's do the study check in the next problem. Down at the bottom, it says that we've got 2,500 milliliters of boric acid, and we want to know how many quarts are in this number of milliliters. Well, if we go back to our table, we know that 946 milliliters is equal to 1 quart. So we want to know how many quarts. We start with what we were given, and then we set up our conversion so that we cancel out our milliliters. So we're going to put milliliters on the bottom, quarts on the top. 1 quart, 946 milliliters. So I'm going to have 2,500 divided by 946 is going to give me 2.6427 in my calculator. But I need 1, 2, 3, 1, 2. I need 2 significant figures. Remember, we are using the sig figs in this conversion because it's a measurement. All right. So we need 2 sig figs, and my answer is 2.642. So we'll say 2.6 quarts. Okay. Let's try a different type of conversion. Everybody get this? Got it? All right. All right. So saying that here that a doctor prescribes a dosage of 0.15 milligrams and tablets are provided in 75 micrograms. We want to know how many tablets. So if I need 150 milligrams, and what I have is 75 micrograms per tablet. How many tablets? All right. So notice that I have milligrams here and micrograms here, right? So I'm gonna have to do a conversion in there somewhere. So let's get started. I want to know the number of tablets. It's going to be equal to what I start with is 1.015 milligrams times, I need to go from milligrams to micrograms. So if milligrams is 10 to the minus 3, and this is 10 to the minus 6, between 10 to the minus 3 and 10 to the minus 6, there are 3 decimal places. So I can say that there are 10 to the 3 micrograms and 1 milligrams. Why do I say 10 to 3 micrograms? Because the micrograms are smaller and I need more of those to make up the milligrams. All right, so here's my conversion, but I want it to be so that I can get micrograms because my tablets are in micrograms. So I'm going to put micrograms on top and milligrams on the bottom. And then finally, I want to know, I need to cancel out here, but I still need to know how many tablets. So one tablet contains 75 micrograms. So micrograms cancel out. So I get 0.15 divided by 75, which should be 2.2, if I'm not mistaken. 0.15 divided by 75. Oh no, I was a little off. 0.002 times 10 to the 3. So if this is times 10 to the 3, I'm sorry, 1, 2, 3, because my number is going to get larger. So that's 2. And how many sig figs do I need? Well, I've got 2 here, and I've got 3 here, so I need 2. So my answer needs to be 2.0 tabs. Well, I mean, okay, 2 tablets. I mean, they're actual tablets, right? All right. So this explains what we've just done. We went from milligrams to micrograms to the number of tablets, and we have our conversion factors down there. Okay, let's try another problem down the study check on the bottom. Oops, I'm sorry. You got that right? You could always rewind me if you didn't. All right, so the study check question says a bottle contains 120 milliliters of syrup. If 1 teaspoon is given 4 times a day, how many days will elapse before a refill is needed? So I have 200 milliliters, and as my dosage is 5 milliliters 4 times per day, right? So the question is asking how many days for a refill. Well, if I'm given 5 mils 4 times a day, that's going to be 20 milliliters per day, right? So, number of days, we always start with what we're given, 120 milliliters times what? 1 day over 20 mils, and that's going to give us 6.0 days. All right, well, we've got 6 days, so 6 days. Okay, in 6 days we would need a refill. All right, let's try these conversions as well. Excuse me. Now you are going to have to practice these clicker questions. I'm going to give you some of these when we have class on Thursday. I'll put that in an announcement so that you'll know. All right, an antibiotic dosage of 5 milligrams is ordered. If it's supplied in 250 milligrams in 5 milliliters, how many milliliters do we need to give? So we need 500 milligrams, and we have 250 milligrams per milliliter. Sorry, how many milliliters do we need to give? Well, we start off with what we want, and we need 500 milligrams, and every milliliter contains 250 milligrams. So that's just going to be, I'm sorry, I can't divide, or can I? Oh, I'm sorry. It's per 5 mils. Excuse me. So 500 divided by 250 is going to be 2. 2 times 5 is 10. So we're going to need 10 milliliters. So what's our answer? 10. Dun, 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 dun. All right, moving on. How many hours and minutes are in 20 kiloseconds? So I'm going to erase this. Well, so we want to know how many hours and minutes in 20 kiloseconds. So 20 kiloseconds is 20,000 seconds, right? So we know how many hours there are, or how many seconds there are in a minute, and how many minutes there are in an hour. So the number of minutes is going to be 20,000 seconds times 1 minute over 60 seconds, which is going to give us, let's see, to 20,000 divided by 60. It's going to give me 300. That's a long number. Minutes. All right. So let's, you know what? Let's do it the other way. I'm sorry. Let's do, I'm sorry. Let me back up. We needed to just continue that a little bit. Instead of finding the minutes, let's find the hours. 20,000 seconds times 1 minute over 60 seconds times 1 hour over 60 minutes, right? So, I'm sorry. So all those cancel out, and we end up with 5.55 hours, right? So we've got our 5 hours. We want to know how many minutes in 0.55 hours. So 0.55 hours times 1 hour, 60 minutes. And from that, we get 33.3 minutes. So the answer is what? 5 hours and 33 minutes. Let's see. Dun, 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 dun. That's our answer. All right. Let's try one more of these. So this question is asking us to completely convert 28 miles per hour to kilometers per, I'm sorry, 28 miles per gallon to liters, I'm sorry, kilometers per liter, right? Instead of 28 miles per gallon, we want kilometers per liter. So I have a gallon. So I want to go from miles to kilometers, and I want to go from gallons to liters. So first we have to have our conversions, and we can say that we have, oh man, I didn't write that one down. Hold on one moment. Let me collect the conversion factors. Okay, I'm back. I got the required conversion factors. All right. So, well, we can get from miles to kilometers. That is 1 km, 0.621 miles. But in order for to get from gallons to liters, we've got to get from gallons, 1 gallon is equal to 4 quarts. And then we've got to go from 1.06 quarts equals to 1 liter. All right. So we want to know how many kilometers per liter. All right. So we start with 28.00 miles per gallon. Wait, let me draw this different so I have more room. Miles per gallon times 1 gallon per 4 quarts times 1.06 quarts per 1 liter, right? So that gets rid of my gallons, gives me liters on the bottom. And now let's get rid of our miles. So I need 1 kilometer, because I need km on the top, to 0.2621 miles. And so now my miles cancel out, and I'm left with kilometers over liters. So I get 11.9 when 11.9 kilometers per liter. So remember how you put this in a calculator. It's going to be 28 times 1.06 divided by 4 divided by 0.621. Okay? So you can get the proper answer. Dun, 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 dun. The answer is B. All right? Density is the last topic in this chapter, and density, because it's equal to mass over volume, we can utilize this mass over volume fraction or equality to do different calculations. So if you're given the density and the mass, you can calculate the volume. If you're given the volume and the mass, you can calculate the density. If you're given the density and the volume, you can calculate the mass. I said that one already? Well, you got the idea. All right. So here we have density, grams over centimeters cubed or grams over milliliter. Grams over centimeters, or centimeters cubes and milliliters are interchangeable. Usually we use centimeters cubed for solids and milliliters for liquids. So you've got to remember density is always going to be in grams per mil or grams per centimeters cubed. Density of gases is given per liter. You can calculate the volume of a solid and then its density by taking the mass. And then you can have a graduated cylinder with a known volume of liquid. You put the solid into it, and then we have a displacement of the volume. So this is called the volume by displacement. And if we have 35.5 mils to begin with and 45 milliliters to end, then you know that you have about 9.5 milliliters or centimeters cubed for the volume of this solid. So let's do a couple of problems involving density. All right, it says that Ken is a 195-pound male patient. He has a blood pressure of 6 grams per milliliters. What is the mass in grams of Kevin's blood? Well, some of this information we don't need. We don't need to know his weight because it's not talking about his weight. But we do need to convert from quarts to what? Milliliters, because the density is given in grams per milliliter. So we're given quarts of blood and the density of the blood, and we need to know the grams. So we're going to go from quarts to milliliters using a US metric factor, and then from milliliters to grams using density. So here we have our conversion factors. Let's carry out the problem. So we want to know the mass if we have 7.5 quarts, and the density is equal to 1.06 grams per milliliter. So what is the mass? Always start with what you're given, 7.5 quarts, and the conversion factor for quarts to milliliters is 1 quart for 946 milliliters. And so that cancels out our quarts. And we can use our density, grams over mils, to give us our mass. And remember, this is a fraction, so we can put it in either direction, okay, in order to do our calculations. So 1 milliliter per 1.06 grams cancels out our milliliters, and we get here, let's put this in the calculator, we get 7.5 times 9.46 times 1.06. Oops, no, not 9.46. 946 times 1.06. So we're going to get 7,520.7. And we have 3 sig figs, 3 sig figs, and 2 sig figs. So that's going to be 7,500 grams. That's really not that much. That's 7.5 kilograms. Okay? Let's do another density problem looking at study check 2.13. Did everybody get this? All right. Okay, the next problem says during surgery, a patient receives 3 pints of blood. How many kilograms of blood were needed for transfusion if we're given the density, which is 1.06 grams per milliliter? Well, we're using the same density, but now we want to know pints, right? And we need to go from pints to milliliters. So we've got 3.0 pints, and the density is 1.06 grams per milliliter. So we've got to go from pints to milliliter, and we need to now also go from grams to kilograms. So if we want to go from pints to milliliters, there are 473 milliliters in 1 pint. And grams to kilograms, we know that there are we can say 10 to the minus 3 kilograms in one gram. All right. So we want to know the mass in kilograms. So we're starting off with what we're given, which is 3.0 pints times this first one here. We want to make sure that we cross out. So we're going to put what on the top? Milliliters, right? So 473 milliliters, 1 pint. So that cancels out our pints. And then we need to use our density to get how many grams, right? So I'm going to do 1 milliliter times 1.06 grams. And then I hope you can read this on the end. The last part, 1 gram to 10 to the minus 3 kilograms. Why did I use 10 to the minus 3 kilograms? Well, it takes 10 to the 3 grams to make 1 kilogram. So if I swap that around, 3 kilograms to give me 1 gram. So if I carry all this out on my calculator, I'm going to get 3 times 473 times 1.06. And that gives me 1504.14 times 10 to the minus 3, because I like to leave my exponents to the end. I don't like to put them in my calculator. You could also have done 0.01 kilograms, and then you could have put that in the calculator. So if I'm going to do 10 to the minus 3, 1, 2, 3. So because that's going to be 1 point, what? I've got 2 sig figs, 3 sig figs, 3. So my answer needs to have 2. So that's 1.5 kilograms. Okay? So 3 pints of blood weighs about, or has a mass of 1.5 kilograms. All right, let's do a couple of density calculations. Using other samples or something other than blood samples. So this question is asking, what is the density of the rock what is the density if mass is 1.075 kilograms and the volume is equal to 334.5 milliliters. Well, we can change this mass to grams because remember, density is only going to be in grams. And so kilograms is 10 to the 3. So we move that over. So that's 1075 grams. All right. And the question is asking what's density. So density is mass over volume. So all we have to do is plug in chug. I've got 1075 grams all over 334.5 milliliters. And if I put that into my calculator, I'm going to get 1075 divided by 334.5. I get 3.2137. So if I'm looking at everything, well, I need how many sig figs? 1, 2, 3, 4. 1, 2, 3, 4. 3.21, and I need to round off this 3 to a 4, and that's going to be grams per milliliter. So what's our answer? Dun, 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 dun. There's our answer. Let's do another. What mass of mercury occupies 20.4 milliliters if it has a density of 13.6 grams? Well, remember before I said if you're given two of the factors in the equation, you can figure out the other. So here you're given the density and the volume, so you can figure out the mass. So density is mass over volume. So if I rearrange this situation, I get density times volume is going to give me the mass, right? So this question says, what is mass if the volume is 20.4 milliliters and density is 13.6 grams per milliliters? So mass is going to be 13.6 grams per milliliter times, we don't need that, 20.4 milliliters. It's going to give us 13.6 times 20.4, 277.44, but we have 1, 2, 3, 1, 2, 3 sig figs, 277 grams. What's our answer? Dun, 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 dun. Okay. Now, one last thing. If you wanted to determine the volume, so if density is mass over volume, and I wanted to know volume, then I can density times volume is mass, and then I'm going to get volume is equal to mass over density. So if you're given the mass and the density, you can then calculate the volume. And that is it for chapter 2. See you on Thursday with chapter 3.